Okay, so you all wanted a cheat sheet as well for the physics exam. Well, spoiler alert, you're not allowed a cheat sheet for the physics exam. I know, what a shame. However, it might be a good idea just to sort of run through once more all the things that are probably going to be in the physics exam anyway. And that is actually half the reason why I provide a cheat sheet for most of these anyway, because I don't think you'll catch me a single time during the thing looking at the cheat sheet. It's just about really getting those ideas into your head by writing them out, and obviously that's just what note-taking is, and that's a valid study method. The first unit we're going to look at is motion in 2D, and so you need to know Newton's three laws: the law of inertia, F equals ma, and action-reaction. So the first one, obviously, if something's moving and I'm not acting on it in any way, there's no drag force, there's no me pushing it, it's just going to maintain its velocity. F equals ma, that's an equation. You get the mass and the acceleration, you can find out the force. You can do it any other way, as long as you got two knowns and one unknown. Action reaction, that sort of is more of a qualitative question. I remember there was a question that if I sort of am in space and I throw a tennis ball in one direction, then I'll start heading in the direct opposite direction due to this action reaction law. Then we talk about net momentum. The net momentum of an isolated system will always be zero. Kinetic energy, half mv squared. Potential energy, depends on what you're talking about, whether it's gravitational, it's mgh. That's just equations as well. Inelastic, elastic collisions, isolated systems, a system without drag, without something else pushing it from the outside. And then kinematics, that's using maths to figure out velocity, knowing that velocity is a derivative of displacement, that kind of thing. Electromagnetism is obviously electrical fields and magnetic fields, which are very different. The electromagnetic field intensity, so you can calculate that using an equation. Motion in an electromagnetic field, so how is a charged particle going to start moving, stop moving, be influenced while it's moving through the electromagnetic field. The forces in an electromagnetic field, I've said electromagnetic field quite a bit. The forces are about how is that field going to, I guess, force a charged particle in a certain direction, that kind of thing. Common electromagnetic fields are interested in if there's a wire with a current going through it, then obviously the right hand rule, it's sort of, the electromagnetic field can be visualized as sort of rings of field going around it. Bar magnet fields, solenoid coil, velocity of particles in a magnetic field. Electrical induction, how do we create voltage from changing magnetic field. Transformers, how do you sort of transform a certain voltage to a different voltage using two inductors. Relativity, the Lorentz factor, that's just an equation. If you know the velocity, you can find out the Lorentz factor. Relative time experienced, so we know that the time of a particle is equal to its Lorentz factor multiplied by the real time, and same with its length. The final topic is light and atoms, and this one's pretty big. It's sort of just about light, not necessarily just being a particle. Figure out what a wave does so it transfers energy from point A to point B without transferring any matter. The double slit experiment and the diffraction experiment are, light waves traveling through certain slits or through a lens, and there's some equations you need to know just to have an unknown, and you can just solve for them in the exam. Absorption and emission, just know absorption and emission lines of certain atoms. Tell me, what does that actually mean? How many different energy levels can an electron change between in a given state? And then the standard model, there's a finite number of fundamental particles, just memorize all of them. There's 6 quarks, 6 leptons, and 4 bosons, so just memorize them. I've written charges and energies as the last line here, but I don't know what that means because it's very, very vague. That's about it. Thank you.